Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In today's class, we will discuss knowledge representation using semantic networks. In previous session, we have seen what is knowledge representation, what are the approaches of knowledge representation. And in that, the first one is semantic networks. What is the semantic networks? How it will be represented knowledge as a semantic network? We'll see in this session. The overview of this session is introduction of semantic networks, and we'll see one of the example of how we'll represent the text into the semantic networks. And what are the objects, what are the attributes, what are the prop links, we'll discuss in this session. Let's see the introduction part. Knowledge representation using semantic networks. So here, what is the basic idea? The basic idea applied behind this semantic network is that meaning of concept derived from its relationship with the concepts. So there are multiple concepts will be there. With that concept, we are linking the relations between the concepts one to another, and we will draw the network to that concept. And that information is stored by interconnecting nodes with the labeled arcs. So there are interconnections, arcs will be there, directions will be there. There are solid lines and there are some dotted lines. So what is that solid line? What is that dotted line? We'll see. Let's see one example. For example, consider the following knowledge. There is a knowledge is there. How we will represent this knowledge as a semantic net, we'll see. So every human, animal and birds are living things who can breathe and eat. All birds can fly. Every man and woman are human who have two legs. A cat has fur and is an animal. All animals have skin and can move. A giraffe is an animal and has long legs and is tall. A parrot is bird and is green in color. John is a man. This is the knowledge. We need to represent this knowledge as a semantic net. So here we can represent this knowledge using a structure called semantic network. Or in short, we can call it a semantic net. It is conveniently represented a graphical notation. I said already, we will draw the semantic network. So where nodes represents concepts or objects like a living thing, birds, humans and animals. And arcs represent the relation between two concepts. So there is a solid line and there is a dotted line arcs. Alternatively, it can be described as a directed graph consisting of vertices representing concepts and edges represents the semantic relation between the concepts. So that nodes can be easily added. If you add some more knowledge to the same knowledge, then it is easy to add that into the network. Let's see the graphical representation. So human, birds, animal are the living things that can eat and breathe. So these are the attributes or properties of this living thing. This living thing is the super concept or super class, we can say. So all living things can eat and breathe. That is either human or bird or animal. Any living thing can eat and breathe. That's why we have given that properties to this living thing. If you observe, there are two types of arcs are there. One is a solid line, another is representing the dotted lines. The solid line represented with the easier. This easier nothing but the relation of the two concepts. One is a subconcept or subclass, another one is super concept or superclass. So here the human is a living thing, bird is a living thing, animal is a living thing. Under living thing, these all are the living things only. Okay, so we can say human can eat and breathe, bird can eat and breathe, animal can eat and breathe. I said already, when we use inheritance concept in this knowledge representation, it is easy to draw the network No need to write multiple times the same properties to each and every subclass. If you write that properties to the top one, then all these subclasses can inherit these properties. And we can represent specific attributes to that subclasses also. If you observe this one, after bird, there is a parrot. Parrot is not a class. Parrot is a instance of this bird. Parrot is a one of the bird. If you take pigeon, pigeon is a one of the bird. Okay. But if you take all birds can fly. So that will be applied to parrot, that will be applied to pigeon, that will be applied to sparrow. So all birds can fly. That is an attribute or property of these birds. And parrot is the instance of a bird. And it is not a ECA. It is not a class. It is an instance of the class. Okay. Next, if you observe here, there is a color in green. And here, this green color is specific to parrot. This one is specific to parrot. If you write a sparrow and if you link the same, it is not like that. This color in green is only to the parrot. That is one of the specific attribute or property to that parrot. We can't write this green into this living thing because all living things not have this attribute. So the specific attributes will be written to that specific concept or object. And overallly, which is applied to all, that will be written onto the top. So living thing can eat and breathe. So parrot can eat and breathe. Okay. If you take another example, animal is a living thing, giraffe is an animal, cat is an animal. The subclasses of that animal. If you take animal has a skin, animal can move. These two are properties. So giraffe has a skin, cat has a skin, cat can move, giraffe can move. These two properties to that all animals. That's why these two properties are written into this animal. So we can't write this tall and long legs to this cat. We can't write these two onto top of that animal because these two are only specific to giraffe. Giraffe is a tall and giraffe has long legs, height tall and has long legs, and cat has fur. So in such a way we can represent a specific properties and general properties. So if you write all properties individually, then it might create some confusion. It is a redundancy properties. That's why general is different. So the general properties can used by all the classes, subclasses of that parent class. Here also if you take human is a living thing, man and woman are the humans. Next, John is an instance of the man. Mary is an instance of the woman. So this is how we can represent a semantic network. And this one, we can say it as a property. So we can represent with the prop link. In short, we'll see in the next diagram. And here, these concepts will be represented with the square nodes, rectangle nodes, and these attributes will be represented with the oval nodes. So here, in the above figure, we notice that the concepts or objects are related to each other by certain relations. The relations are represented in the figure by bold directed links. They may be defined as easy. The relation connects two classes where one concept is a kind or subclass of the other concept. For example, man is a human. That is, man is a subclass of the human class. Next, inst or instance. This relation relates a specific member of a class, such as John is an instance of the man. Next, other relations such as can, has, color, height are known as property relations. These have been represented by dotted lines pointing from the concept to its property. property. In this structure, property inheritance is easily achieved. For example, the query, does a parrot breathe? Can be easily answered as we. Why? Because parrot is a bird is a living thing, and living thing can breathe. So we can easily answer that as. Even though this property is not associated directly with the parrot, it inherits this property from its superclass named living thing. Okay, let's see here. I already said the concepts or objects are represented with the square nodes, and the properties are represented with the ovals. The same diagram here, and here we have given some link called as a prop. All attributes are written as a prop. So look at here, 2 legs, tall, long legs, property to all that. Next, easy and inst links have well-defined meaning, whereas other links which connects attributes of class vary in their interpretations based upon the concept having attributes or properties. It will vary. The semantic net interpreter can't understand all the attribute links unless their semantics are encoded into it. So directly has can, the living thing can eat, can breathe, and giraffe height, tall. So that prop relations will vary. So one concept to another concept. All the attributes of the class are the properties. We can designate a unique names to such relations as prop link. Due to giving the can eat, has fur, has skin, can move, having the different relation names. So instead of giving the different relation names, simply we are giving the prop link. So to all the attributes, we can give the prop. So the interpretation of prop link will be simple, that attributes attached to a class in one of its properties. Next, in the above figure, square nodes represent concept or objects connected with a easy or inst links, whereas oval nodes represent a property attributes attached to the square nodes. Okay. Next, inheritance in semantic. That is what we have discussed. That is, hierarchical structure of knowledge representation allows knowledge to be stored at the highest possible level of abstraction, which reduces the size of knowledge base. So if you give the breathe and eat to each and every concept, then the network will create some confusion and redundancy will be happened. So that's why here we are using inheritance, so that it will have some highest possible level of abstraction and it will reduce the size of knowledge base. Since semantic net is stored in as a hierarchical structure, the inheritance mechanism is built and facilitate inferencing of information associated with the nodes in semantic net. And it is a natural tool for representing taxonomically structured information and ensures that all the members and subconcepts of a concept share common properties. That is what inheritance is, which shares the common properties. It also helps us to maintain consistency of the knowledge base by adding new concepts and members to existing one. Without interrupting the existing knowledge, we can easily add the new things also. Properties attached to a particular concept can be easily inherited by all sub-concepts and their members. Let's see the algorithm to retrieve property of an object is given below. Okay, so here we'll see how to retrieve the property of an object. So this is the algorithm. So the input is object and property, and output, if the object contains the property, then returns as, otherwise it returns no. The procedure is find an object in the semantic net, initially found equal to false. Next, we need to check the condition, keep on until unless the particular object contains the property or not. That's why we are taking the help of while loop. So here the condition is object not equal to root and or found equal to false. Then if there is an attribute attached with that object, then found equal to true. else object is a object comma class or object equal to inst object dot class, and keep on repeat the same procedure until it will get that specific object contains the property or not. If it is yes, if found equal to true, then report yes, otherwise return no. Next, semantic net can be implemented in any programming language along with the inheritance procedure implemented explicitly in that language. Okay, in this we'll use a prolonged language is very convenient for representing the semantic structure in the form of facts and rules. So let's see. So these are the prologue facts. What we have seen that diagram, the same diagram we have taken and we represented the facts. So easy facts, instance facts and property facts. Just we have taken the diagram and we represented the same here. So easy, what are the easy? First, living thing having. So living thing, there is no superclass to that living thing, that's why we have taken nil. Next is a human, living thing, animal, living thing, bird, living thing, man, human, woman, human, cat, animal. In such a way we can write like that only. This is what from that knowledge base. Next, instance fact. Instances. John is an instance of man. Giraffe is an instance of animal. Parrot is an instance of bird. Cat is an instance of animal. Here it is wrong. Here it is instance. Next, property facts. Prop is the relation name. Breathe, living thing. Eat, living thing. 2 legs, human. Skin, animal. Move, animal. Fur, bird. Fur, cat, not bird. Cat. Prop. Tall, giraffe. Long legs, giraffe. Tall, animal. Green, parrot. Next, inheritance rules. What we have seen, all these are the facts and these are the rules. So here for instance, the rules, instance of x comma y, if instance of x comma y, inst x comma y. Next, instance x comma y, inst x comma z, subclass z comma y. If you take inst x comma y, John is a instance of man. John is a instance of man. Then we can write subclass of man is a subclass of human. We can rewrite like this. If John is a man, then man is a subclass of human. Then we can write John is a human. From this knowledge, we can infer the new knowledge is John is a human. In the same way, subclass rules. Is a x comma y, is a x comma z, subclass of z comma y. For example, if you take is a of man comma human. Next, man comma living thing. Man comma human, human comma living thing. Then we can infer that man is a living thing. Next, prop links also in the similar way we can infer that. Next, various queries for inheritance program we can write like this. Is John human? Instance of John comma human, we can infer that John is a man, man is a human. Then we can say that yes. Next, instance of parrot comma living thing. Yes, parrot is a bird, bird is a living thing. Then we can say yes. Instance of giraffe comma animal, giraffe is a animal. So we can say yes simply. Subclass human comma living thing. Yes, human is a subclass of human, human is a subclass of living things. And then we can say yes. Property. Fly is a property of parrot. Yes. Fly is a property of bird. So parrot is a bird. So we can take that. Does parrot have a fur? No, because for animal, cat will have fur. Next, John is a property. Breathe. Yes, because a living thing have the breathe property and John is a living thing. Next, fly property is a cat? No, because it is for birds. In such a way, we can answer all the questions based upon the semantic network. So, in this session, we have learned what is a semantic net and what is the inheritance concept and how we can write the facts and rules in prologue using this semantic network, how we can answer the questions to that. In next session, we will see the extended semantic networks. Thank you.